In this video, we're going to talk about position, velocity, and acceleration. So position we've already talked about, right? Position of an object is the distance from the 0 point to the object in a particular direction. So there's a couple of fine points that you need to take note of. One is that position is a vector quantity. So it has both a magnitude and a direction. So for one-dimensional, that should say motion, the magnitude of a position is its absolute value, and the direction is just the sign of the position. So that's really all we need for for the direction in this case. So if we have a position function f and we plug in a 2, so for time 2 we get a -3, right? What that indicates is that the point is 3 units from the 0 position right here on your number line or coordinate system. And the negative, right, indicates that it's over to the left. So on the number line, all we really have is a right and a left, right? And so the negative indicates, hey, it's over here to the left of the 0 point on the number line. So the direction, right, is just the sign, whether it's positive or negative for one-dimensional motion. Of course, it gets more complicated when you go to 2 and 3 dimensions, but we don't have to worry about that for this class. All right, and position is going to be measured in linear units, like such as feet, meters, miles, etc. Those kinds of units there. So what we're after here is we want to describe the motion of a particle. And for us, we are going to know the position function, right? And so that gives us the position of the moving object. But some other questions that you would probably want to know if you want to describe the motion is, hey, how fast is the object moving? What direction is the object moving? And is the object speeding up or slowing down? Okay, so those are the sorts of questions that we would want to answer. All right, so the next thing that we would be concerned about is the velocity. And so the velocity of an object is the rate of change of the position with respect to time. Okay. Velocity is a vector quantity, and it has both a magnitude and a direction also, just like position. And for one-dimensional motion, right, again, just exactly the same with position. The magnitude of the velocity, right, is just going to be the absolute value of it. And in everyday language, we usually just call that speed. Okay. And the direction is going to be the sign of the velocity, and that tells us which way the particle is moving, right, on the number line. So here's an example. Here I have the position function again, just like in the last example, f of 2 is -3. That tells us the location of the particle on the number line. And we're going to call v the velocity function. And later on we'll show you how to find the velocity function. But just for now, just say we have such a thing. And when we plug in a 2, right, at 2 seconds, we get a 5, right? And so what that indicates is that this particle has a velocity of 5, right, units per whatever time unit. Say if we were measuring these distances in feet and the time in seconds, right, this would be a velocity of 5 feet per second. That tells us two things, right? That in the next second, right, the particle is going to go about 5 feet, right? So you can see that indicated kind of with this arrow right here. This arrow is 5 units long. So in the next second, right, or so, the particle will wind up to be over here around 2. Okay. Whether or not it gets there exactly at 2 kind of depends on whether this particle is speeding up or slowing down, right? If it's speeding up, well, then it's going to get there faster than or get farther than 5 units away. If the particle is slowing down, right, then it might take longer, right, to get to over here to 2 than just a second. So that depends on the acceleration there. But if the particle continued to go at the velocity that it's going at 2 seconds, right, and it didn't change, then basically what would happen in the next second, right, it would go 5 feet. So it would wind up right over here. Not only that, right, you can see that the sign of the velocity, it's a positive number, right? So that indicates that the particle is moving in the positive direction here, not in the negative direction. Had we got a -5, then the particle would have been moving in the negative direction to the left over here. Okay, so that's what the velocity function is going to tell us. Velocity is measured in linear units per time unit, right? Such as feet per second, meters per second, miles per hour, etc. Right? So what that indicates, right, is that, you know, if you're going 5 feet per second, then every second you're going to go 5 feet farther, right, during that time. So it's a measure of your how fast you're going, right, and also in the case of velocity, what direction you're heading in. Again, for us, because we're on a number line, the directions are either a plus, right, indicating you're going in the positive direction, or a negative sign and minus, right, indicating that you are going in the negative direction. That's all we need. Okay, so that's what velocity is. Also, what we'll want to know is acceleration. The acceleration of an object is the rate of change of the velocity with respect to time. So it's how fast your velocity is changing. Okay. And it is also a vector quantity. It has a magnitude and a direction. And similar to the other quantities, the magnitude is just the absolute value, and the direction is the sign, right? So positive, you're accelerating in the positive direction, and negative, you're accelerating in the negative direction. So here, let's call A the acceleration function, right? And so if we plug a 2 in for the time variable, after 2 seconds, let's just say we get, as an example, -1. So what that would indicate, right, is that this particle is accelerating in the negative direction right here, 1 unit. So what we would say is that if everything stayed the same here, then what we would expect is that in the next second that the velocity would go down by 1 unit. So in other words, at time 3, right, then the velocity would be 1 less. You would subtract 1 per second if we were measuring the time in seconds. Okay. So the acceleration is this way. You can see that the motion, right, is headed in this direction, the velocity. The particle, right, is heading in this direction right here, but it's accelerating in the opposite direction. And so when you have that, when the direction of the acceleration opposes what the velocity is, what that means is that the particle is slowing down, right? It's putting on the brakes, basically. It's accelerating in the direction opposite of the motion. So the velocity is going to decrease, right? And if everything stays about the same, for instance, it's going to be in the next second going about 4 feet per second, let's say. And so its velocity is decreasing. On the other hand, had the, say the acceleration was a positive one here, this arrow would kind of be pointing in this direction. And what we would expect there is that if everything stayed roughly about the same, that in the next second at time 3, right, we would have been adding 1, right, to the velocity. And so the velocity would be about 6 feet per second there. So in the case that the velocity and the acceleration are in the same direction, what that means is that the particle or object would be speeding up. So by comparing the velocity and the acceleration, we can answer those questions that we asked before. When is the particle speeding up? When is it slowing down? Which direction is it traveling in? How fast is it going? So we can answer all those questions with the velocity function and the acceleration function. So what we're going to do after this is focus on, well, how do we come up with the velocity function and the acceleration function? And the answer is going to be pretty easy, but it will take some explanation to get there. The answer is that if I have the position function, the derivative of the position function is the velocity function, and the derivative of the velocity function is the acceleration function. But it's going to take some explanation as to how that works. That's not super obvious when you first see that, but we'll go through that. Okay, and the units for acceleration, right? Acceleration is measured in linear units per time unit squared, right? Such as feet per second squared, meters per second squared, and miles per hour squared. Okay, and so that what that is right, acceleration is the rate of change of the velocity, right, say measured in feet per seconds, with respect to time. So it's a matter of how much your velocity is changing every second, right? And that would be a foot per second, let's say. And if you simplify that out, an easy and convenient way to write it is feet per second squared instead of feet per second, or meters per second, or miles per hour, right? It's just nicer and more convenient to write that as miles per hour squared or meters per second squared. All right, so that's it as far as the background ideas for velocity and acceleration. And next up, what we were going to do is figure out how to come up with the velocity and acceleration functions and how that's related to the derivative.